Hello class, this is Ms. Riggins with today's video, basically summarizing conic sections. We've talked about three conic sections, and we're actually going to introduce a fourth conic section that you're already familiar with, but probably didn't know was a conic section. And we're going to basically summarize the results and see how they're related to one another. So we've talked about the equation definitions in implicit form and also parametric form, but I want to remind you about the definitions geometrically of the conic sections. And some of these you may already know. So let's start with our first conic section, which is a circle. And it says that a circle of a radius r is a set of points in the plane a distance r from the given point. And the given point is, of course, our center of our circle, our HK. So let's take a look at a demonstration of that. Here's our center, C, and our point, P, and our R is our constant distance. And as you can see, we have a circle. Okay. The next conic section we looked at was an ellipse. And the definition of ellipse is the set of points in the plane for which the sum of the distances to the foci is constant. And if you recall, we have a formula to determine the coordinates of the foci based off the center and the A and B constants that are a part of our ellipse, where the two focus points, or the foci points, lie on the major axes. And there's a constant sum of the distances. Of the distances is the length of the major axes, i.e. 2a if it's opening, if it's wider than taller, and 2b if it's taller than it's wider. So let's take a look at a demonstration of that. So basically imagine a string attached to the ends, like we did in class, and then pulling the pencil around to create this shape. So here we have our ellipse, and if I want to change the constant sum, that changes the size of the ellipse, or if I want to change the size, I can do that as well. But we already did that in class, so we're okay. Okay, so that's definition of ellipse. And the word locus is basically a collection of points. All right, let's move on. And so now let's talk about the third conic section we looked at, which is a hyperbola, which in this case is the set of points or the locus of points in the plane for which the difference of the distances to two focus points is constant. And here we have a general formula to determine the location of the focus points based off the center of the hyperbola as well as our A and B constants. So that's what we just had a test on. So let's take a look at a demonstration of a hyperbola. So let's go ahead and move this around. And as you can see, since the difference has to be constant, it looks something like this. And if I want to change the distance, the constant difference, that will affect the size of the parabola as well. And again, F1 and F2 are our foci, and this represents our constant difference. All right, now let's move on to the other conic that we haven't talked about, but you already have experience. So the last conic section is a parabola. And I know you say, oh, we've done parabolas before, and those have been in the context of their explicit equations. But a parabola, by definition, is the curve, is a set of points in the plane for which the distance from a focus point, which can be determined from the vertex of the parabola, is equal to the distance from a fixed line. That line is called the directress. So let's take a look at an example of this. So here we have a focus point, and here we have a directress, which is a line. And every point on our parabola will have this property, that the distance from the point to the focus is going to be the same as the distance from the point to the line, i.e. the directress. And remember, to find the distance between a point and a line, we look at the perpendicular distance. So these values will always be the same. So let's go ahead and look at that. And as you can see, the values of the distances are changing, but they're changing at the same time. PF is always going to be the same length as PD, where PF is the distance from the point on the line, on the parabola to the focus point, and PD is the distance from the point on the parabola to the directrix. And there we have this equation where we all know here this is the vertex, and we label this HK, and the vertex is on the line of symmetry. Okay, so I know this is a new concept, even though you've been dealing with parabola because we've not been looking at it in this sense or with these glasses on. But by definition, another definition of a parabola is a collection of points in a plane where the points are equidistant, i.e. the same distance from a fixed point, which is the focus, and a fixed line, which we call the directrix as well. Okay, and I want to show you something. If I were to change the location of the directrix, let's see. That's going to affect the parabola, basically changing the location of the directrix and changing the location of the point, the focus. Will also change the shape of the parabola. But one thing does remain the same is that the distance from the point to the focus remains is the same distance as the distance from the point to the directrix. Okay, all right. I've included in the notes an image of a parabola opening up and down. Now, I do want to point out, even though we could get into this, we're not. What happens if the parabola is not opening up and down, but what happens if the parabola is opening left and right? Well, you're going to have a similar type situation with a little slight changes. The axis of symmetry is not going to go through the x coordinate of the vertex. The axis of symmetry is going to go through the y coordinate of the vertex. The directrix is not going to be a horizontal line. It's going to be a vertical line as well. So, and we'll talk about that a little bit later. Well, we may or may not. I also want to point out that your book uses, instead of A, like I've used to correlate with this picture, the book uses C to represent the distance from the vertex to the focus. So sometimes it's used as C, and I've also seen it used as P. So that's a little bit tricky. But we're going to be consistent with what the book says, and so the book uses C, but this picture uses A. So I just want you to be aware of that. Okay? All right, that's it. Have a good weekend. I'll see you Monday.